So hi everybody, my name is Fraser Cain. I am the publisher of Universe Today, and this is your virtual star party for Sunday, September 23rd, 2012. We've got an action-packed night tonight, although it's going to be the monochrome edition. I can see this already. So let me just give you sort of a rundown of who we've got joining us, and then we'll sort of give you guys a bit of a preview on what we're going to be able to be seeing tonight. So working the telescopes right now, we've got this beautiful view of the moon, and this is supplied to us by David Dickinson. And David, where are you located?
Hey, I am located in Hudson, Florida, just north of Tampa Bay.
Right, and so you want people to know that if the moon appears to be underwater, that's because of your atmosphere, which is like 50% water, right?
Pretty much. It's pretty humid here.
Yeah.
Whenever the AC kicks on for the house, you'll see it turbulence kick up.
So we're joined by the rock-solid Gary Gonella, who is testing out his new software that he's created for the team, which is really cool. And so if there's anyone else out there who is looking to share photographs in a Google Plus Hangout, I highly recommend you check this out. So we'll post a link to it in the thread at some point. But it's cool because he can just drop images onto his folder and they're automatically shared into the Hangout, really quick and really crisp. So I really like this. We got Mike Chasin, who is in you're in San Diego, right, Mike?
I am relaxing comfortably in my home in San Diego and looking out at our desert observatory that's about 70 miles east of me in the high desert at about 3,400 feet.
And this is an all-sky view right now, showing what your sky is looking like.
Exactly, and you can see the bright thing down towards the bottom of the display is the moon, and that glowing red in the top left is not actually the setting sun like we would hope. That's actually about a 1,000-acre brush fire that missed our San Diego Astronomy Association deep sky site by about 1 mile. So fortunately avoided us. Unfortunately, it did burn down about 3 or 4 other homes.
Whoa, that is crazy. So in other words, right now the horizon is on fire for you.
Literally
on fire. Wow. Has anyone ever been near like a really big forest fire? Like I'm completely tangenting.
I've been in a forest fire.
Yeah, that's true. You used to be a firefighter, so yeah, no,
it sucks.
Yeah,
not fun.
All right, we're going to move to Paul Stewart, and what looks like a sort of monochrome ball is actually filled with sciencey goodness. Paul is in New Zealand. And this is a view of the sun seen from New Zealand. So we're seeing the nighttime sky, and we're also seeing the daytime sky, which is every kind of awesome. Especially because Paul is using a hydrogen alpha filter, which is the special filter that shows us the atmosphere of the sun. And we're going to kind of come back around and spend some time examining the sun, looking at sunspots, and we're going to try and look for some prominences, which are these great big blasting flares and stuff off the surface of the sun. So I think this will be really cool. We've got Ray Sanders, we've been led to believe, but I think he's just left us with his view of the moon. So this is, and we haven't heard from him since he shared us this view of the moon, but it's a beautiful view of the moon, so we're not going to say goodbye to it. So thanks, Ray. We got Roy Salisbury, who is operating his remote telescope from his home in Las Vegas, and so now tonight is the night. He's been delivering some beautiful pictures so far. So I think, but you had some high clouds there, right? Yeah,
there's a few high clouds, but hopefully they won't get in the way.
Good. Don't let them get in the way. And then we've got Stuart Forman, who is, there you go, there's a nice picture, we'll get back to that in a second. We've got Stuart Forman, who's working in the dark. You can see there, you can just see some glimpses of his, of his flashlight in the camera.
I'm almost ready, I'm just frame and focusing right now.
Oh, perfect, yeah, no problem.
I'll speak in Morse code for the rest of the night.
We've got a lot of telescopes tonight, so I think we're good. And then joining us for color commentary, we've got my good friend Scott Lewis, who is fresh off of a day of moon observing from the International Observe the Moon yesterday, which was fantastic. How many telescopes did you have yesterday, Scott?
I believe 11 total, and a few got clouded out, and my entire outreach on site was clouded out, but we had 11 from across the globe, so it was fantastic.
Yeah, what an absolutely crazy day, so that was fantastic. And then we've got Dr. Thad Szabo, who is a professor of astronomy, or physics, actually. And where are you teaching again?
So physics and astronomy. I'm at Cerritos College in Norwalk, California. So
perfect. So we'll be relying on you to bring the science.
That's what I'm here for. No pressure. No worries.
Well,
So what do we
real
have
quick, Fraser, I'm going to drop out, get our Stellarium up on my other machine since we're full up, and we'll get everything going.
So we've got the sun up in the main view right now.
So, Fraser, you're muted.
Sorry about that. I was coughing. Right, sorry. So we've got the sun here, and Paul's been having some really high clouds, so I don't want to lose the sun while we get a chance to view it. So can you sort of explain what we're seeing here? I mean, obviously it's the sun, Thad, but I think there's something really special here because it's a hydrogen alpha filter.
Right. So I mean, the sun, like most stars, is made about roughly 3/4 hydrogen, 1/4 helium. There's going to be some trace elements. Anything heavier, actually, when we deal in astrophysics, is considered a metal. So oxygen's a metal, nitrogen's a metal, argon would be a metal. But so the sun's a more accurate representation would be 74% hydrogen, 24% helium, and then a trace of these metals, about 2%. So the hydrogen alpha filter selects the light that comes specifically from hydrogen, so it lets us see features in the sun's atmosphere from the hydrogen that is excited by the energy of the sun. And if this picture was in true color, it would be red. The light that we'd be getting from hydrogen through this filter is in particular just red. And so what we're seeing right dead center, actually pointed right at us, is a sunspot group. This is an active region. It's one of these places where the magnetic field of the sun has gotten all twisted up and pokes directly out of the sun. So underneath it, you don't get hot gas and hot plasma flowing quite as well. So instead of being a absolutely broiling 9,000 degrees Fahrenheit, it's a pretty darn broiling 7,000 degrees Fahrenheit. But because it's slightly cooler, it appears darker. And the one reason we want to monitor these regions is because they could produce solar flares or coronal mass ejections, which could then spit nasty sun spitting at us, but it could spit protons and helium nuclei out at us, and that could affect, well, it could cause some really pretty auroras, or it could affect satellites. It could affect the orbits of satellites, and if one came that was really powerful enough, it could actually also affect electrical transmissions and possibly shut down the grid on parts of northern latitudes around the Earth.
Now, I don't know if this is coming through, but I can almost see like the surface of the sun is all mottled, and
Yeah, I mean, I can see some of this super granulation. So underneath the surface of the sun, the layer that we can see, which is called the photosphere, there are hot gases rising up from inside the sun. As they release their energy, they cool, and then they sink back down. And so the gas that's hotter tends to be a little bit brighter. The gas that's cooler tends to be a little bit darker. So you do get a kind of mottled pattern over the surface of the sun. And so that's a little bit of what we're seeing here. There's these kind of supersized granules. Now each one of those blotches, just for reference, that spot that's in the middle of the sun, that's about the size of the Earth. So if you were holding up the Earth and comparing it to the size of the sun, it would be about the size of that sunspot that's right in the middle of the field of view. So those granules, or excuse me, supergranules, are much larger than the size of the Earth.
Right.
And it looks like we also have some other features. Looks like we have some filaments that are crossing the sun toward the left edge, I guess at around like 9 o'clock, and another one at the lower right edge down around like between 3 and 4 o'clock on the sun. So these are loops of hot gas that are arcing above the sun. But because we're looking through them to see the sun, they just look like kind of a darker line, a darker feature over the top of it. Still really nice shot there. Nice shot.
It's a beautiful shot. So there's a couple of things we're going to try and push his observation a little bit. But before I do, someone just reminded me on the comment. So this is a totally interactive experience. We have 1, 2, 3, 4, 5, 6, 7 telescopes tonight for your observing pleasure. So we're going to start sort of running through various objects that we can see with the telescopes, but we're more than happy to take your requests, and we'll try and showcase anything that we can see in the night sky. And I think when Scott's ready, he's going to sort of give us a bit of a preview of what objects are up and what we might be able to see. So there's a bunch of ways that you can provide your comments. The first place is if you're watching this on the event itself, where you said yes, you wanted to watch it, you can post it. You can post a question there. If you're watching this on Google Plus, you can post your comment into the questions there. If you're watching this on YouTube, we can take your questions there. And the last thing is, if you're watching this embedded somewhere else, we can take your questions just using, on Twitter, for example, just use the hashtag StarParty, and we will be able to spot that. So, so now, Paul, can you hear me okay?
Loud and clear.
Perfect. And you can see he's got his authentic New Zealand accent, so I think everyone can see this is all completely legit.
Watch out for those fake New Zealand accents. They'll get you every time.
Yeah.
Every time.
So can you try zooming in on one of those, on that big sunspot group that's right in the middle there? I say zooming in, but that's sort of a ridiculous thing to say, I know. Enhance and magnify.
Oops.
Okay. There was that other sunspot that you had before. Is it?
It's here somewhere.
There it is.
There it is.
Yep. Perfect.
Oh yeah.
Yeah. Look at these sunspot groups here. Someone is typing.
Yeah,
this is coming through a 12-inch with a white light filter on it. So there's no longer hydrogen alpha.
Oh, you've actually switched the filter.
I've switched to a second scope.
You switched to a second scope?
Very nice.
Wow. That is crazy. So now I don't know if it's coming through in the view, but you can actually see that the sunspot has kind of two colors. There's like a darker center and then a sort of a lighter outside part.
Right. So any sunspot group, there's just like with a shadow, there's a region called the umbra, and then the lighter region called the penumbra. Now, this is not a shadow that we're seeing on the sun. This is just a darker region. But the center part is where the magnetic activity is the most intense and cutting out the flow of hot gas the most. And then there's a region around it where it's still cut out to some degree, but not quite as much. And so another thing that you can kind of see is that none of these sunspots are alone. They always are going to come in pairs. So one part where the magnetic field kind of pokes out of the sun, and then another part where as it arcs over top and goes back into the sun, you get these two sunspot regions on both sides there. So any sunspot you get is bipolar.
So the sunspots are usually paired up, right?
Right.
Yeah.
In some cases, I mean, the two spots are so close together they just look like one large umbral region. But yeah, it's always going to come in pairs like that. And I mean, we can see that large group that's visible to the left of the shot, and then there's some smaller groups visible to the right. If you were to look at the sun with, say, ultraviolet light or X-ray light, like you could with images from the Solar Dynamics Observatory or any of these other solar observatories that are out there constantly imaging the sun, you would see a huge glow from this region in the ultraviolet or near X-ray region of the spectrum. So although sunspots are darker using visible light, if you look at them with these higher energy photons, the region glows quite intensely. In fact, the sun actually has slightly higher output when it's active, when there are sunspots present, than when there are not.
And so the other thing I wanted to see, so I just wanted to highlight the sunspot, and then the second thing is, because you got this hydrogen alpha filter, Paul, if you can switch back to the other telescope, I cannot believe you got two telescopes going here.
That's great. That is great.
Yeah, can we try and see the limb and see if we can see some prominences? I think we saw one over on the left-hand side there. There. So what he's doing here is he's changing the brightness of the sun so that it washes out the front of it, but you should be able to see any kind of material that's being kicked up in the atmosphere of the sun.
Right.
We saw something a little earlier. Yeah, it's pretty small, but you can see it over on the left-hand side there. Oh, there's something down at the bottom there too.
Bottom right.
Yeah.
Yeah, and I mean, small is quite a relative thing here. I mean, it's small compared to the size of the whole disk, but like that prominence that's sticking up off the lower right there, and there's another one at the very bottom of the image that's currently showing. Those are actually both bigger than the Earth. So the Earth would fit neatly under that rain of that arc of hydrogen gas that's being spewed above the surface of the sun and crashing back down into it.
That's amazing. Very cool. Okay, well let's move on then. I think so. Paul, we'll sort of keep this going in the background, and if anything interesting happens, we'll if the sun explodes, for example, something like that, we'll come back to you. But let's move on right now.
It's not going to explode, but just for members of the audience who might think otherwise. But...
So, Stuart, you have just brought us something. What is this?
This is Albireo. It's a double star in the constellation Deneb, and it's my absolute favorite.
That is fantastic.
And you can see why it's my absolute favorite, because it's blue and gold. And
Yeah.
I went to the University of California, whose colors are blue and gold. So it's my favorite.
Yeah. So we've got it. Sorry to say this, guys. We need to bring Mike Phillips is sort of standing by, and he's got some images. So we need to bring him in. I'm going to drop Ray because you're just a blank screen right now, and then we'll bring you back in later, Ray.
And we also have Mark Behrendt waiting too, and it's his birthday.
And it's his birthday. Okay, so we're going to drop Ray. Sorry, Ray, I just ejected you. I've never done this before. I don't want to block him, though.
It says ignore.
I don't want to block him. No. Wow, that's kind of hardcore. I just want to be able to drop him from this. Okay. All right, so we'll let... I think, Mike, are you going to be able to get a view, or are you kind of done for tonight? Because I wouldn't mind bringing in Mark and Mike if we can. So.
Hey, Mike, you there?
Uh-oh. All right, I think I will. Okay, so can you let Mike and Mark know?
There I am. Yeah, you can let me know. You can let me go. That's fine.
Okay. All right. So can you just drop for now, and then we'll. But if your sky clears up, let us know. Okay.
Will do.
Okay. Well, thanks. That was on. Mike's got a great view, and it's a real shame that his horizon is on fire.
And I sent invites to them, so they should be coming in soon.
Okay, cool. So, and while we're getting Mark and Mike in, Scott, do you want to sort of show sort of what the sky looks like right now? We've got a handy dandy Stellarium going.
Handy dandy Stellarium, and again, this is not exactly what the sky looks like because I have removed the atmosphere, which many people wish they could do, and I can only do it on a computer. But so, starting with last night, we have our moon, which we had a fantastic time doing the International Observe the Moon night. So over here we do have our waxing gibbous. So it's coming along. We were at first quarter yesterday, and it's in Sagittarius right now,
which is pretty low to the horizon for us folks in the southern hemisphere.
Are you in the southern hemisphere?
It's in the northern hemisphere. Sorry, okay. It's close to the. Sorry, it's close to the. In the south. Sorry.
Fake New Zealand accents. I'm getting what you're trying to say now. Okay.
He's in the northern part of the summer
the northern hemisphere, southern hemisphere. Yeah.
So again, this is looking almost due south here.
Yeah.
And
there's the teapot. You can always recognize Sagittarius by that teapot.
We have a little teapot. It's short and stout. And here's its handle, and here's its spout. But we have over here. We do have Capricornus. And we can just actually go through. We have Aquarius, which most people know of, and you can actually see, I'm not sure if it's coming through in a hangout, but we are seeing the Milky Way Galaxy through here, which we are a part of. We are looking into it because we are inside of this. So every star that you're seeing right now is because we're in this galaxy, which is freaking awesome. And with Scorpius, Centaurs, Libra, and Mars is very low. I can actually zoom in here real quick.
Yeah. And Mars is going to be going down in minutes. So.
And its moons, Phobos and Deimos.
There you go. Cool. And then Jupiter is going to be coming up in the east shortly, but not for us.
So
well, maybe for Mike if Mike is able to join us.
So here's the horizon. Here's Jupiter.
below the horizon.
It's well below the horizon.
For us on the West Coast, but perhaps Mike on the East Coast, they'll be able to see it.
Yeah.
Hey, Mark just joined us. He brought the moon.
I did.
Happy birthday, Mark.
Well, thank you.
Yeah, happy birthday.
Happy birthday.
That's awesome.
Thanks. So, a birthday present I got from the president of my local astronomy club here is a manufactured in 1974 Celestron C8 telescope. So that's what I'm looking at through tonight.
It's a C.
C8. It's an 8-inch.
Okay.
It's an 8-inch catadioptic.
Is
Schmidt
Jupiter
cast.
up for you yet?
Not yet. It won't come up for another probably hour or two to where I can see it above the tree line.
Right. Okay. No problem. Well, that's beautiful. That's just absolutely fantastic.
Fraser, Jupiter comes up here in about 20 minutes from Florida, but we've got clouds rolling in here, so I don't think
I can see that. Yeah. Sorry, David.
Yeah, the moon will probably peep out here like on again, off again over the next few minutes.
All right. Well, we'll go back to that moon because it's just gonna. Man, that's just great. I've heard a few people are putting like this star party up on their like big television screens, and this is the kind of view that you want. It's great big view of the moon. That's just fantastic. Wow.
Yeah, so my moon is getting close to behind a tree here, so I'm hoping to try a new trick this week. After the moon is out of sight, I'm going to try and find a glob or something to look at.
Yeah, we'll be able to get a good test. Yeah, a good test of comparison for you.
Yep.
All right. Well, I want to go back to what Gary's got because it is absolutely phenomenal. So, Gary, what is this?
This is the M16 Eagle Nebula.
Oh,
and this is at my full frame, and this is at the resolution I took the picture. So we can zoom in a little bit and see the pillars of creation in here.
And you're using your handy-dandy new piece of software you created for this,
yes.
right?
Yes.
Yeah.
Double-click
that's
and
phenomenal.
Double-click and
that's
zoom
gorgeous.
into where I was. And I noticed that Roy's got the same thing in color.
That's awesome. So here's
looking at it in color.
So there's Roy's view in color.
Yep.
Well,
I'm trying to get. I've got about another 30 seconds to get the final. Final frame for color.
That's just gorgeous. And so you can see the pillars of creation there, right?
Yes.
Right there.
So pillars of creation, and also in that zoomed out view, you can see just how extensive the gas and dust, well, especially in this case, the hydrogen gas is through this region of the galaxy. But those places where it's a bit darker, I mean, the reason they're called pillars of creation, there are stars forming inside that region right now. But I mean, here with this zoomed out view, you can definitely see some of the faint wisps off to the left side of the frame. It gets really dark on the right edge of the nebula there. So that's not that, it just disappears, but that's darker, cooler material obscuring some of the glow behind it. And then, yeah, when we zoom in on the pillars of creation, you really get some of this contrast between cooler, dark material with these long, spindly regions where there's star formation going on, and then the parts that are just getting bombarded with ultraviolet light and glowing very strongly from the hydrogen spectra. But there's some really good detail in there. That's a nice shot. Nice shot.
Thank you.
So, Stuart, are you setting something else up there?
Yeah, give me 30 seconds.
Okay, no problem. I just didn't want to, unless there was some important science going on there and I didn't know what it was.
There it is.
Okay. Oh, is that the double in
Lyra.
Oh, that's Lyra. Okay.
Yeah, love double. It is indeed another one of my favorites.
Very nice.
You're in a double star mood tonight.
Or quadruple star in this case.
Yeah. Is that actually like a binary?
Yes. This is one where you have two binary pairs, so each of those two pairs of stars, the close companions, orbit each other, and then each of those pairs also orbit about a common center of mass. So you're looking at a rather complicated dance where you have the two stars orbiting each other like this, and then those two pairs. Okay, we got the hairdryer going.
Is it the hairdryer, or is that Stuart moving his...
But
that was me, Stuart.
Yeah, okay, he's slewing, okay, to his next object, yeah.
But then the two pairs also go around each other. Kind of like, if I could back up more from my webcam, I guess you might be able to see it. But so,
yeah.
Prestidigitation.
So just, again, once again, if you guys have any questions for us, you can post your questions onto the event page, onto YouTube, onto the Google Plus page. You can use the hashtag Star Party, and we will answer your questions. So there's a few questions here. Shugo Amukusa asks if it's possible to see the U.S. flag on the moon. It is not with the technology we have from here on Earth. So
that's right. The Lunar Reconnaissance Orbiter was able to see the shadow of the flag on the Apollo 16 mission, and that was released rather recently, I believe.
Yeah.
So you were able to actually see the shadow from there. It was awesome.
The flags are still standing, yeah.
Well, except for, I think, Apollo 11, I think that one actually fell over.
Yeah.
But the fact that we can see that the flags are up at the other 5 Apollo landing sites and not at the Apollo 11 site is pretty incredible for the level of technology we now have out, observing the moon.
So I just had a request for M3. Can anyone do M3? That should be up, right?
It's in. I don't know if that would be
fairly low.
Yeah.
Yeah.
Because that's in like northern Virgo or Boötis or Canis Venatici.
Yeah, it's going to be low to the west.
Yeah, that's hanging around underneath the Big Dipper.
It's in Canis Venatici, correct. It's not far from Arcturus, actually.
Yeah, so it's going to be really close to that Mars, which Scott told you was going down.
Yeah, it's too low for me.
Let's go back to what Gary's got. I believe I see a Dumbbell Nebula. And my kid's
exactly
running overhead.
That's the M27 dumbbell.
And I'm working on getting the same thing, but with color.
Cool.
Whoa, that's good. It's great to show the difference because, we mentioned this before. Gary is operating out of Los Angeles, which is this incredibly light polluted skies, and so in order to be able to see things in the night sky, he switched to a hydrogen alpha filter, and this is the same kind of filter that Paul's using for this version of the sun, and it's a wavelength of light that's able to kind of get through all of that horrible light pollution and bring you this really crisp details, but you sort of get this monochrome, you get the monochrome view. And so what Gary does is he's actually got a bunch of different filters he can run. He can run this hydrogen filter, a sulfur filter.
Sulfur and oxygen
are
the 3 main ones I use.
And then build up a color view of this object with using those 3 filters as colors. But the dumbbell is beautiful. It really looks like a dumbbell.
Yeah, with those planetary nebulae like this, that's what you want, is to be able to stack those 3. So this is going to be the fate of our sun, given about 6 billion years or so. So again, although we still have that view of the sun from Paul, that's pretty much the view that will be there for the rest of our lives. No worries about that. But when the sun runs out of hydrogen to fuse into helium in its core, it will swell up to a red giant. The outer layers of the sun will then be at essentially the radius that matches Earth's orbit. So bye-bye Earth at that time. Again, you've got 6 billion years, though, so don't worry about this. But then it will lose its outer layers. The hydrogen will drift off into space along with some oxygen, some other elements, and so when you're looking at these planetary nebula like M27, you're getting hydrogen. Any bluish color is coming from blue-green color is coming from ionized oxygen. So building one up with the various color filters lets you kind of see the different contributions from different elements to one of these stars that has died. And they don't last very long. They last maybe about a few tens of thousands of years before they dissipate so much that there's not enough material left to reflect or re-radiate the light of stars, the light of the white dwarf that's at the middle of it there. So this is kind of an interesting little snapshot. If you consider the 13.7 billion year history of the universe, here's something that only lasts a few tens of thousands of years. So it's kind of a blink in the eye, and just happening to be around at the right time to see this one.
And it's the same thing with the Ring Nebula. It's just a different looking planetary nebula. Is it with the Ring Nebula, are we seeing it from a different perspective, or is it just a different kind of, the way it died was different?
It's all in the way it dies. I mean, Phil Plait has done a number of articles on planetary nebulae because it was one of his focuses of study when he was doing his PhD. But you get shells of gas that expand away from a star at a certain rate, and then as the star gets closer to dying, other shells can expand out faster, and as they collide with each other, you get different structures glowing. So here, like with the Dumbbell Nebula, you kind of have this bar running from about 2 o'clock, and then down to about between 7 and 8 o'clock, and then you can see some kind of rings around there, and then some farther rings extending out between like 11 and 5. So it's kind of the different layers puffing out at different times as the star goes through its death throes. So with the Ring Nebula, it's very symmetric. Here with the Dumbbell Nebula, not quite as symmetric. You definitely have a little more structure in certain directions than others, and you get some wickedly complicated looking ones like the Cat's Eye Nebula.
Yeah.
But yeah, it's all exactly how does the star die? So, and it's a little different for each one.
So as predicted, Mark said he was going to start losing the moon behind that tree. So I think that's starting to happen now. So we'll see what happens.
So you need to have your neighbor get solar panels like Stewart did, so they'll chop down that tree for you.
So Scott, can you let Mike in somehow? I've invited him a bunch of times, but
well, he was just telling me he was having a problem with the G-Talk plugin. But if he's needing to get back in again, I will definitely invite him.
Yeah. Okay. So here we go. So here is Stewart's version of the same thing, but in color.
It's a little noisy, but you can see it's got a lot of blue in it in the middle, and on the outside it tends to be a little bit more red, and it's just a really noisy image because it's only one shot, but you can get an idea of what the color is in this.
That's beautiful.
Again, the red showing hydrogen and the bluish green showing ionized oxygen. So every element that we consist of that's heavier than hydrogen, because we don't really have helium in our bodies, but anything heavier than hydrogen was made by the death of a star. So so you're looking at stuff getting recycled into space when you're looking at something like the Dumbbell Nebula here.
So sorry to interrupt, but it looks like David lost the moon, and just to sort of make some space for some of the other astronomers, he's going to drop out. So
yeah,
David,
I got knocked off here, so it doesn't look like I'm going to get a clear sky here for the next 20 or 30 minutes.
Well, can you switch back to the camera though, so people can see your view, because you got a nice telescope there. It was pretty cool. I don't know if you can see.
Let me switch over and turn the overhead light on, and that will attract bugs, but that's okay.
Whoa, and I just got distracted by what Gary's got.
Yeah.
Oh, there we go. Well, thanks, David. Thank you very much for joining us and bringing that moon in the beginning. And we'll see you
no problem.
next week.
It started out as a clear night, so yeah, I'll try to make it again next time we do this too.
All right.
And thank you for yesterday as well, David. I greatly appreciate you participating with us in international.
Yeah, that was a lot of fun. Yeah.
And then there were 4. We're losing astronomers like flies here. This is rough.
Bye, David.
Mike's not going to be able to make it. Okay.
No.
All right. Too bad. So, Gary, is that the Propeller Nebula?
That is the Propeller. Okay. I thought I would
Nice.
pull that up since it's one we kind of discovered on the star parties.
Yeah, we discovered it. No one knew about this object until we discovered it.
No one knew it was there. It's part of a huge area of hydrogen cloud, but I love the definition in here.
So we've got a question here on YouTube. Dan Foley, PGH, wants to know if that's live in Stuart Scope. And yeah, that is the sun right here, live from New Zealand. Awesome.
I did see a request for M110, would be the satellite of Andromeda Galaxy.
Yeah. I saw another request also for M11. Not to split up our deep sky people here, but M11 should be pretty nicely placed too, just above the moon, I would imagine.
And what about M11, and then it'd be nice to do Andromeda as well if we can. It's getting high in the sky now. It's great. I go for walks at night, and I just boom, there's Andromeda. I live in a very nice dark. I've got pretty good dark skies where I live, and so yeah, you can see the Milky Way, and you can see Andromeda rising up in the east. I love the propeller though; that's beautiful.
Yeah.
There's a bunch of these objects. I mean, this is great. Gary puts together this list of objects, and he's just like, I don't know what this is going to look like. Let's find out. And then he shows it for the first time, and sometimes it doesn't work out. And then a few of them, like the propeller and Thor's helmet and a few others, have just been fantastic.
Yeah, it'll be a few months before we get Thor's helmet back.
Yeah. Well, but we're almost about to get the Orion. And then that'll be all we talk about. Right. Okay. So a few more questions here. So someone wants to know how the nebula got that kind of a shape. How would a nebula get this propeller shape? Is something going on, or?
Let's see. Yeah, I mean it's kind of random. It's not. I don't think this is. This doesn't look to me like a supernova remnant. I mean, there you usually have a region that's been hollowed out by the supernova explosion. I think this is just simply an emission nebula. So regions where gas and dust has usually been pushed together through kind of the spiral density waves that go through our galaxy. So you have this kind of deal where you'll have material in the galaxy that kind of bunches up as it rotates, and those are regions that can kind of trigger star formation. So you'll find them along the plane of the galaxy. I'm not actually even positive where in the sky this is. Is this in Cygnus?
It's in
Cygnus.
I believe it's Cygnus.
Yeah.
Cygnus. Okay, so that would be along the band of the Milky Way. So chances are this is just a random assembly of hydrogen that got pushed together as through the galaxy's rotation, as well as the death of some massive stars nearby. And again, if you see it glowing, there has to be one of these O-class, really huge, gigantic, short-lived, brightly glowing stars in there that's flooding the region with ultraviolet light. And then as that ultraviolet light's absorbed, it gets re-radiated as the red light from hydrogen that we're seeing here.
So I just got a question from Paul. I guess he wants to know the size of the various telescopes. I think if I'm interpreting his question correctly. So Gary, what's your telescope? It's a
14-inch Celestron 14.
And then, as we said, Mark's got this C8, so a Celestron 8-inch. What's yours, Paul?
The Hydrogen Alpha is a 60 mil, and the Meade is a 12-inch.
So just a 60 millimeter. That's not a big telescope.
For the sun, you don't really need it.
No, I know the sun. Right. The sun is providing its photons for us. So, and then Roy, you've got a 8, right?
I have a 106 millimeter refractor and an 8-inch SCT. Yeah.
Are you taking a picture of the Elephant's Trunk Nebula?
Yes, I am.
Wow, there you go. And then Stuart, you've got a 140 millimeter refractor.
Exactly.
Yeah. All right. There we go. There you go. And I'm trying to think. What do you have, Thad?
Well, packed up downstairs. I've got the 9 1/4 inch Celestron Schmidt-Cassegrain, or Edge HD. So.
And Scott, you've got access to, what is it, a 12-inch Meade at school?
Yeah, we've got a 12-inch Meade LX200. We've got 12 C6s.
Nice.
And then I'm using my 12-inch photon emitter called my monitor, which gives you Stellarium.
Yeah.
So.
And then I've got my 4-inch Celestron Nexstar, so, which I will be at some point attempting to stream, but it's going to be hard.
Oh, and I also have my binoculars, which we should always remember. Binoculars are great to have if you're doing astronomy. I've got 15 by 70 millimeters, and they're portable, great for spotting what you want to see.
So Dan Foley just asked on YouTube. I hope that was what you wanted to see. You got to see Gary's telescope actually slewing to its target. So how awesome is that? So just for people to understand, if we're doing the moon and the planets and the sun, then that's live. So literally, you just take the camera, you point it towards the object, and it's live. Multiple frames per second, 30 frames a second. For the fainter objects like this Dumbbell Nebula that we've got right now, or the Propeller Nebula that Gary had, then this is a longer exposure. So what they'll do is, like, for example, they'll run it for 30 seconds or a minute, collect all the photons, and then post the picture. But
both of those were 1 minute.
Yeah, those were a minute. Okay, yeah. So this is all essentially live. And Roy has just posted. Maybe we can do another side by side. Well, I'm not sure what Gary's moving on to, but this is another favorite as well. And so Roy, can you tell us what you're showing?
This is the Elephant Trunk Nebula. It's not coming out as good as I'd hoped. It's a 2-minute exposure, but I'm shooting through some clouds, so it's just not. I really need a longer exposure through these clouds. So you can see that over on the right-hand side, you see some of the nebula there, but the rest of the lighter areas are just the clouds reflecting back.
Yeah, so it's we had this last week, and so nice to see the comparison. But yeah, you can see that sort of dark nebula there. Oh, okay. Gary just posted Andromeda.
Yeah, if you want, I can do like a 5-minute exposure of it and see if I can pull more out of it.
Well, let's move to another object.
Okay.
Move to another object, because it sounds like it's not. Yeah, a 5-minute exposure would be crazy. That's madness. That's like that's not live. That's like astrophotography. So what did somebody want to see? How about the Great Globular Cluster in Hercules?
The M13 one?
M13, yeah.
I can get that in a second.
Sure. Okay, that would be great. So let's look at Andromeda. Whoa.
Yeah.
And I've got a 2-minute one exposing right now.
This is just a 1-minute one?
This is a 1-minute exposure.
Because I think this is one of the nicest views of Andromeda you've done.
We've got some good skies in LA tonight.
Yeah, it's very clear tonight. Here's the companions, M110 and whatever the other one is.
So M32. So M110 and M32. But I mean, yeah, the bright bulge in the center there's a supermassive black hole buried in there somewhere that's got a mass of several tens of millions of times the mass of the Sun. And so it's orbited by a lot of stars, a lot of very bright stars nearby, and then you see it kind of fade away, and then you have these dark lanes out past it there. So again, the spiral arms in Andromeda don't show up all that well using visible light, but you can still make out some of these regions of darker gas and dust that could be collapsing to form new stars. And then on either side, up in the upper left corner of the picture, is one of the satellite galaxies to Andromeda, and then that fuzzy ball off due right from the center, from the nucleus of the Andromeda Galaxy, is another companion or satellite galaxy of Andromeda. So just like you can have a star with planets going around it, you can have a galaxy with companion galaxies orbiting it.
And I just turned to the 2-minute.
Oh wow!
Yeah, wow. And so you can see those clusters in the dust lanes there.
Mm-hmm.
Mm-hmm. Oh, that's just fantastic. Wow.
And I've got a wide field of view, and this galaxy's bigger than my field of view.
Yeah. Yeah, just what is it? It's like 3 moons wide and 2 moons high, right?
So close to 5 full moons wide from one side to the other. And about 2 full moons high. So, and then being able to see the companion galaxies off to the side, the one up in the upper corner there, that's that's a good like 3 full moons off from the 3 or 4 full moons off from the center of the main spiral galaxy there. So, yeah, this is a huge field of view you've got there. That's really nice.
Yeah, I love it. Okay.
And this is with the fast star arrangement, correct?
Yeah. So okay. I'm shooting at f1.9.
And although we say it's live, I mean, the thing is there's a finite speed of light, so even the view of the moon is technically 1 1/4 seconds old. The view of the sun is technically 8 seconds old. If we bring up Jupiter, if somebody on the East Coast is able to get in and bring it up or so, then that would be about 40 minutes old. When we're looking at the Andromeda Galaxy here, though, that's 2.5 million years ago that this light left to get to this telescope.
Yes, so there, Fraser. It's not live.
It's not live. It's true. It's 2.5 million years old. I apologize. So, question from Adam: how far away are those satellite galaxies from Andromeda?
Let's see. So, I mean, the whole Andromeda Galaxy is about a little over 100,000 light years from end to end. So we're talking within 100,000 light years of the center. So, yeah, still, I mean, yeah, if you were taking light from one of the satellite galaxies, the time it would take to reach the core of the main galaxy in the picture is still on the order of tens of thousands to 100,000 years.
Yeah. Oh, man. That is an amazing picture. And Stuart has brought us another favorite. Look at this.
This is the Ring Nebula. It's another planetary nebula that's similar to the Dumbbell Nebula in that way, and it's also in a similar area of the sky.
I just love the colors that come out of this in full color. Like you could just see that green center and that red ring around it. It's an amazing object.
So again, very thin ionized oxygen producing the greenish bluish glow, and hydrogen producing the reddish glow. And I think I would have to check whether it's sulfur or helium that produces the kind of yellow region in the middle. We were just doing a spectroscopy lab in my my astronomy labs this past week, and helium definitely glows with a yellowish or kind of peachish glow when ionized. So I wouldn't rule out helium, but I've also heard that that sulfur can produce roughly the same color as well. So.
By the way, Gary, your software rocks here. This is awesome.
This has made people's lives a lot easier, yeah. Cool. I'm going to go to... So Roy, as requested, has brought, what, M13?
M13.
Yeah.
Yep.
Oh, that's what I just got.
Oh, no! Let's compare and contrast. I don't know.
His is a little more focused.
Yeah. That's amazing. Look at that. Wow. How long is your exposure on that one, Stuart?
1 minute.
Mine was 10 seconds.
He outdid you, Roy. Sorry.
Well, give me a minute.
Well, then he'll have 2 minutes. You're always going to be behind.
That's so
competitive
cool.
Astronomy. I don't know. That's
what
kind of like Eddington and Campbell, or
Okay, I'll just get along. Okay.
As long as that full contact.
I will. You know what? I will send one of you on a new mission. How about M110?
Okay.
Actually, I believe you just had M110 up when we had Andromeda.
In the field of view with
Oh no,
Andromeda.
sorry. Then someone was
M11.
The Whirlpool one.
M51.
M51. Yeah. M51.
Those are
Maybe
going to
a
be
little,
fairly low.
maybe a little low, but I can give it a try.
Okay.
So I do remember seeing a request in the YouTube comments for M11, which would be just south of Aquila the Eagle. That should be fairly high up, and it doesn't really have nebulosity, so the moon wouldn't wash it out either.
Someone asked for
just a
M7.
suggestion.
Is M7 up?
Barely.
I should get my Stellarium happening.
It's very low.
Oh,
Yeah.
Is it low?
Yeah, that's off the
13
tail of
degrees for me.
Scorpio, so that's going to be
Yeah.
a tough one.
Yeah.
Sure,
Too
Scorpius.
Scorpio.
We are losing these objects now. It's time for the winter objects, the fall objects.
Well, let me see what I can get.
That everyone's been bugging us for
I know.
months and months.
When will we be able to see Andromeda? Right here is when we'll be able to see Andromeda. Enjoy.
I don't want to see that. I want to see your summer constellations. What are you talking about?
When we'll be able to... Yeah.
What do you mean yesterday was the equinox? I want to see summer stuff.
We all love you. We're just giving you a hard time, viewers.
M51, yes. Nicole has reminded us that it's M51.
But we can hear you vicariously through Nicole. So, Tim, we can hear you. Just from her comment.
Somebody wanted M33.
I can do M33.
Can you do M33?
I might be able to. It's a little low, but I can try it.
Let me see.
Depends on the size of it. How big is M33?
It's a triangulum. It should be okay. It's just below Andromeda.
It's a little under a degree across.
Yeah, I can do that. It's 24 degrees. We'll try it.
Gary needs a new target. Or Gary's got a new target.
I have a new one.
This is new. What is this?
Actually, did look at it. This is the Cave Nebula, which you can kind of figure out where it got its name.
Is Yoda sending us there now?
Might be.
Okay. As long as we don't have a failure there and the fake Darth Vader doesn't show up. So.
I just have to say the best part of Gary's software is that I can actually watch the Hangout now while it's going on. Before, I wasn't able to see any of this stuff. This is awesome.
That's amazing.
That is awesome. Very welcome.
Yeah.
It didn't take long.
Nice work.
Really?
Well, you needed to get it to work with FITS files.
Yeah, probably could.
Here come the features, Gary. Don't resist.
Feature requests and ETAs are going to be blowing up your email.
Yeah.
Oh, well.
So is the cave in Cygnus or Cepheus? Where are we looking here?
I'm going to go back and look. I've got it, and then I moved away.
It's also known as Caldwell 9.
So I'm putting up an image here, which has come from one of our friends. This comes from Ron, and this is. Can you guys guess what this is?
A blank screen.
No, this is your coat hanger.
This is the coat hanger.
Oh yeah, it's upside down, right? The bar is oriented against kind of from like 10 o'clock down to 4 o'clock or so.
Yeah, and so each week I've sent astronomer after astronomer to try and gather us an image of the coat hanger net cluster, and they have come back empty-handed, or only being able to resolve part of it. It's actually a really big sort of object, an asterism. So, but here you can see it. So I don't know if you can see, but there's sort of the line of stars there, and then there's this the hook part of the coat hanger, and it's fantastic in a pair of binoculars. When I first saw it, I was like, oh wow, that's really cool. So
this is in roughly the same part of the sky as Alberio and the Dumbbell Nebula.
Yeah.
So,
and to answer your
right
previous question, Cave Nebula is in Cepheus.
Okay.
That's really cool. Well, thanks, Ron. That was awesome. Well, one thing just to remind people is if you are watching this on Google+, you can actually post pictures into the event.
Yeah.
And so you can actually take snapshots, and if you've got your own pictures or other objects you want to show, it's pretty cool because then it sort of shows you this timeline of all the things that are happening. So you can do that from the event page. Anyone who's watching can just go to the event and they can just post pictures into the event, and then they sort of get stored for all time. It's quite neat. Someone is asking if we have anything to do with SLU. We do not. They're other people who have telescopes that they broadcast, and it's really cool. So, people want to know about Stellarium. So Stellarium is the software that Scott was screen sharing. It's free. It runs on Linux. It runs on PC. It runs on Mac. It's a fantastic piece of software. I highly recommend it. So just grab it free, and I think they even have a version that works on Android, iPad. Yeah, it's a great piece of software.
It is great, and they have different resources that you can download with it, so different star packs, more data, and I believe you can also contribute your own astrophotography into Stellarium, so you can actually fill up your own night sky in the software with images that you've already taken.
Now, I don't want to... Paul's just getting an amazing view of these sunspots again, so I just want to just switch back to him briefly.
Yeah, so this is the 12-inch visible light or white light view, right?
Yeah, and you can see the seeing has gotten really clear. It's really settled down.
Yeah, those are quite crisp. And I mean, the sun is a very challenging object, for an astrophotographer. I mean, you'd think, well, it's a big ball of light, but the problem is these features are fairly subtle. So getting the light levels right to be able to bring out the detail like this is fairly challenging. So yeah, nice job here, Paul.
Yeah, just fantastic. Just got a question from Neelion Gupta. This is live. So I hope that gave you the confirmation you needed to know that this was live. Let's go back to Stuart now. So Stuart's got a view of M51.
Yeah, it's a bit washed out because it's really low in the sky, but it's there. You can see it.
Yeah, absolutely. That's fantastic.
Yeah, a little bit of spiral arm structure, and then that galaxy that's passing by the main spiral galaxy off to the right of it there. So.
Yeah, it's too low though.
So the lower something is to the horizon, the more atmosphere we have to look through to find it, and so any effects of light being removed by the atmosphere just amplify the closer it is to the horizon. So run outside your house and look straight up and give us things from that region of the sky, No, I mean, because it's going to be different depending on where you are in the world. So don't. That's not good advice. Sorry.
You can take Stellarium, go to San Francisco, and then find things for Stuart to find.
There we go. Yes.
So Roy has delivered, and that's
the tease.
You got a nicer version coming? Okay, well
that's a 10-second one. I'm doing a tricolor 60
Okay,
seconds.
well we'll let you build that one up then. Gary, is this your version of M?
That's the
17?
M11.
This is M11.
Yeah. So this is the wild duck cluster, because a bunch of people gathered around on the deck of a ship sailing across the ocean one time, probably after ingesting a fair bit of rum, looked at this and said, "Oh, it looks like a bunch of wild ducks flying overhead." Okay.
That's the official source of it.
What a bunch of quacks. Seriously.
Oh
yes.
So I think we'll go another probably 10 minutes or so, and then I think we'll probably wrap this up. So.
Let's see, we've got M33, right? Roy is bringing in M33 now.
Yes.
Yeah.
That's a longer exposure version now, isn't it?
No, that's still the.
Still the 10-second. All right. Well, then I don't want to ruin this.
10-second.
All right. I'm gonna go back to Paul. Whoa! Look at Paul's view. It looks like you can see the what are the like snakes on the surface of the sun there? What are those?
So those are filaments. If you look at them at the edge of the sun in hydrogen alpha, those would appear as prominences. When we're looking through them to see the disk of the sun, you don't see them looping out and away from the sun like you can when they're at the edge. But what those snakes are, those are prominences. They're long strands of hot hydrogen plasma that extend up above the surface of the sun and then back down to it. So something else you can kind of see here too, near the large sunspot in the middle of the sun, you can see a slightly brighter area. So these associated with sunspots are also regions called plages, after the French word for beach. And so, yeah, sometimes when you have an active region, you'll get the dark area for the sunspot, but you also get a hotter, brighter area, and those are called plages. So, yeah, there's a lot of
it a sunny beach.
Very, very sunny beach. There's no SPF that'll save you from that one. So,
but Paul's scene has just settled down. It has just gotten really crisp and clear.
Yeah, this is quite a lovely shot of the sun.
Have you been doing something special with your view, Paul, or is it just the sky's gotten clear for you?
Yeah, the clouds have thinned out a bit. Still a bit there.
There's actually still some clouds in front of this. Wow. It's going to get a lot better.
Well, Paul's been my champion for the last 24 hours, so good on you, Paul. You've helped me out a lot.
What else?
I'm working on the Eastern Veil.
Teal asked for NGC 253.
So let's see, that's going to be pretty far to the south, right? That's in Sculptor or Phoenix. So for those of us in North America, it would be off the southern horizon, probably not too high up yet.
Yeah, no,
mine's right on the horizon.
Yeah.
Okay.
Same. So that's not going to work. Sorry, Teal.
Sorry.
Go image it yourself, Teal.
Would you like to see Polaris?
I know you can.
Would you like to see the North Star, Teal? We could do that for you because you're in Australia. What else? Any more questions? Any more requests? Okay. Well, I'm going to. I'll take a quick opportunity here to once again mention our handy dandy Phases of the Moon app that we've been building. So check it out. So this is really cool. So this is the Android version. We've got one for iOS as well. But what's really cool? Check this out. You go, whoa. So we can actually see the libration of the moon, how it sort of goes back and forth, and actually shows
you right the first time. Not libation. That's something we do after.
Yeah, that's libation. And then you can see down at the bottom here, we've actually got I don't know if it's showing. Yeah, so it's actually showing the live distance to the moon as it changes. So it's really cool.
If any of my students are watching, because I know you have to have the phase of the moon if you're doing your Sky Journal entries, go get that. That'll definitely help.
Yeah, that'll help. Yeah, you can get it on the Android store or on iOS. And if you go to Universe Today, there's a link on the sidebar, and you can grab it. Only 99 cents. So there you go. This episode of the Virtual Star Party was brought to you by Phases of the Moon. from University.
But in all seriousness, it is great. I was showing it to some of the students on my campus yesterday when we were doing our outreach, and they're going over the phases of the moon too in class. Like, you can't have this on the exam, but it might help you with your homework. That's a little thought.
I wanted something that you could give to your kid in the backseat of the car while you're driving, and they would be like, "Whoa, look at that!" So, yeah, that was the plan. Cool. There's the veil. Oh, yeah. We got the veil twice.
Double veil. Woo!
Yeah. His is probably way better. This is not good at all.
That's fantastic.
Well, I'm just doing a 60-second of it here. Let me stretch it, and I'll put it up.
Mine sucks. This is horrible. Well, this is awful.
We get some idea of the color from Stewart's view, and then we get more of the idea of the detail from Gary's view. It's okay. We've got both. Each of you has your advantage here.
There's a 60-second.
Oh, now he's just showing off.
Now this is a star that blew up, right? This is a very massive star, reached the end of its life, and exploded. This is about some 6,000 or 7,000 years ago, and what you're seeing here is the gas and dust as it's raced away from it and slammed into other material in the region of the galaxy where it blew up, and so it's glowing quite brightly here.
Well, I think on this note, why don't we wrap things up? So I would like to, as always, give a big thank you to all of our astronomers. Thank you so much to Gary and to Mark. I think you've got something else going on there.
Yeah, I think I have part of the double cluster here.
It's almost like it's too high of a magnification, maybe.
Yeah.
Yeah.
That's a huge object, yeah.
Yeah. That's another good view for binoculars. A big thanks to Paul. Okay, there you go. He was upside down for a second there, but now he's right there.
Yeah, he's upside down all the time for me.
I know. That's a beautiful view of his telescope there. That's fantastic. And there's Mark. Happy birthday, Mark.
Thank you.
And congratulations on getting your hands on a new telescope.
Thanks. Now I just got to figure out how to use it.
Roy is giving us that final view of the galaxy.
Yep, M33.
That's M33. So Augusta Liquid, there's your M33.
Yep.
Thank you very much, Roy. And thank you very much, Stuart. You're scaring me, though. You're like...
I'm so scared right now.
Here's my red.
Awesome.
The Bay Area Blair Witch.
Thanks to Scott, and thanks to Thad. And we will see all of you again next week, right here on Google Plus for another virtual star party. Thank you very much, everybody.
Bye, everybody.
All right, everybody. Good night.
Good night, everyone.
Good night.
Night.